how many pieces do we have to have? 3. So for the first one, you have to start by plugging in the 2, and then you need things less than that. So if you put in 2, you get 3, 1, 2, 0, 1. And it was an equal to, so it's close, it kept going, so we get that piece. Second one, what x values do we have to plug in? Yep, we need 2 and 4, and you do something in between, and all of those we're getting out 3. The 2 did not have an equal to, so that would be open, the others would be closed. So 2, 3, it says open, but it's already closed, so we just leave it closed. 3, 3, and 4, 3. Alright, last piece. You have to start with 4. Doesn't have an equal to, so that's open, and then things larger. So if you put in 4, you get -1. 5 gives us -3. 6 gives us -5. So 4, -1 is an open circle. 5, -3. 6, -5. And so we get that graph. How'd you guys do? Are there any issues with these piecewise functions, either from the homework or this one that we just went over? So the second piece of this section that we have to talk about is the greatest integer function. Did you guys do this one last year? She used to cover it in Algebra 2, but I don't think she did last year. So the greatest integer function, it has like 2 bars around the x. And so what it's telling you is no matter what number you put in, you can only get out integer answers. So integers are like -2, -1, 0, 1, 2. So we can't get out decimals or fractions. You also cannot get out anything larger than what you put in. So if I put in 0, 0 is an integer, I'm going to get 0 out. If I put in 1/2, 1/2 is not an integer. What 2 numbers does 1/2 fall between? 0 and 1. You always give me the smaller one because you can't get out something bigger than what you put in. So if we put in 1/2, we're going to get out 0. If I put in 1.7, what would I get out? 1. 1.7 falls between 1 and 2. You give me the smaller number, which is 1. So it's not which one it's closest to, it's always the smallest. So let's just practice evaluating a few of these. So if I ask for the greatest integer of -3, if you put in an integer, that's what you get out. So we get out -3. If I ask for the greatest integer of 1.99, what do we get out? 1.99 falls between 1 and 2. You give me the smaller number, so we get 1. C, greatest integer of -4.2. So -4.2 falls between what 2 numbers? -4 and -5. You give me the smaller one. Which is -5. Because it's a negative. Think about it, if you plotted it on a number line, you're always going to give me the number on the left. The negatives are the ones that always get people. Is that okay? Let's try looking at a graph. So we're going to graph this thing and answer some questions about it. Greatest integer function, on all of these, every time we draw a graph, the first time we always make a t-chart. It's not really going to help me if I just plug in 0, 1, 2, 3, 4, because what am I going to get out? 0, 1, 2, 3, and 4. We're going to have to put in some decimals here to really get an idea of what our graph looks like. So let's start. If you put in 0, we get out 0. If I put in 0.5, what do we get out? If I put in 0.9, what do I get out? What happens when I put in 1? Okay. So we have 0, 0. 0.5 is still 0, 0.9 is 0, but when I put in 1, I get out 1, so it's going to jump all the way up here. Now, is 0.9 the end down here? Is there anything else I could put in? Could I put in like 0.99? And I would still get out 0. If I put in 0.999, I'm still going to get out 0, right? So what we're actually going to do is put an open circle down here on 1, 0 to show we're going to be down here all the way up until I get to that actual point when I plug in a 1. And that is when I'm going to jump up to the next piece. What happens if you put in 1.5? What are you going to get out? If I put in 1.9. But when I put in 2, I get out 2. So we're going to, at 2, 1, we'll put an open circle. And then it jumps up. So we now kind of see the pattern. These steps, this is called a step function. They're 1 unit long. They have a closed circle on the left, open circle on the right, and then it jumps up 1. So we went the other way. -1 would be a point, and you would be on this step all the way until you get to 0. Okay, so you could keep extending this if you wanted. And these just keep going. All right, what's the domain? What x values can we put in? Yeah, we can plug in all of the x's, can't we? Range, though, am I getting out every possible y value? No. We get out -2, -1, 0, 1, 2. What's another word for that? Integers. The range is the integers. Or the symbol for integers is that double word z. Is this graph ever increasing? No. Decreasing? No. It's constant on each step. Each one of these little lines is constant. Where is this graph discontinuous? So I'm asking where it's continuous, but the easier way might be where is it not continuous? So we have a break in the graph at 0, and at 1, and at 2, and at 3. Those are the integers. So it's continuous everywhere except the integers. Let's look at another example. So I want to graph the greatest integer of 1/3 x minus 2. So to do that, what should we do? What's our strategy for graphing? by teacher. Okay. Let's start with the 0. If I put in a 0, okay, 1/3 times 0 is 0, minus 2 is -2. What is the greatest integer of -2? -2. Okay, so that one is the beginning of a step, and I know because I had an integer inside. Okay, we had the greatest integer of -2. So we had an actual integer value. So that is the beginning of a step. And we're basically going to be on this step until we get another integer in there. All right. So if I put in, what do you guys want to try putting in next? 3. Okay, let's put in, why would you choose 3? Let me ask that.
Because
Okay.
1/3 of 3 is 3. 1. Okay.
So if I put in 3, 1/3 times 3 is 1, minus 2 is -1. And the greatest integer of -1 is -1. So again, this time, the first time we had the greatest integer of -2. That was an integer value, so I knew that was the beginning of a step. This time I have the greatest integer of -1. -1 is an integer, so you found the beginning of the next step. So what's this graph look like? Probably make these a little bit closer together. So when I put in 3, we get -1. What happens if I put in some things between it? If I put in a 1, 1/3 times 1 is 1/3. Minus 2 is -5/3, or -1.6 repeating, so we're still getting out -2. If I put in a 2, I get 2/3 minus 2, so -4/3, so -1.3, which is still giving us -2. So we're down here all the way up until we jump to the next step. So we have to put an open circle underneath that. So we're seeing greatest integer, so we have a closed circle on the left, open circle on the right. These steps are 3 units long, and then you jump up to the next. What I would ask if you're graphing these, minimum of 3 steps, please. So this way I know there would have to be an open circle underneath this. All of the steps will have the same open and closed circle pattern. So once you know it on the first one, you can really just continue it. And I usually put dot, dot, dot on the end just to show that these keep going. Any questions on that? Greatest integer function, it seems like a weird one, but it actually gets used a lot. If you think about like postage, you know, if your letter weighs under a certain amount, you have to put 1 stamp on it, right? And it doesn't matter if your package is 1 sheet of paper or 10 sheets of paper, as long as it's under that weight limit, you pay 1 amount. But then what happens? After it goes over that limit, you have to put a second stamp on it, and for a certain window of values. And then the postage keeps going up. So that is a great example of a greatest integer function. Within a certain window, you're paying 1 set amount. So let's look at this one. I'm not giving you an actual equation. I'm kind of describing a scenario. And we have to come up with a graph for that scenario. So an express mail company charges $20 for a package weighing up to 2 pounds, and $2 for each additional pound or fraction of a pound. Let y equals c of x represent the cost to send a package weighing x pounds. Graph it on the interval 0 to 6. So my x's, I have to go from 0 to 6. my y-axis is representing the cost. What is the lowest cost I'm going to have? 20. I'm going to count by twos. So you'll notice my interval, it starts with a parenthesis. So what kind of circle are we going to start with? Open or closed? Open. A parenthesis means not equal to. So we have to start with an open circle on our graph. And that makes sense because is it possible to mail something that weighs absolutely nothing? No. It may not even weigh a full pound, but an envelope weighs something. Okay, so it would be impossible to have a true weight of 0 here. I know my lowest possible cost is 20, so 0.20 is where I start this, and that would be an open circle. And if my package weighs a ½ pound, or a pound, or 1½ pounds, how much am I paying for all of that? 20, up to 2 pounds. So if my package weighs 2 pounds exactly, we are still paying that $20. So that's my first step. But after that, as soon as your package goes over that 2 pounds, so 2.1 pounds or 2.01 pounds, your cost goes up $2. So my cost is going to jump up to 22 immediately after that. So I'm going to start it with an open circle. And that is for each additional pound. So if it weighs exactly 3 pounds, I'm still just paying $2 for 1 extra pound. So this step is just 1 unit long. But after I go over 3 pounds, what happens to my cost? It goes up another 2. Now we're at $24 for anything between 0 and 4 pounds. And after 4, it goes up to 26 for 4 to 5 pounds. And after 5, we raise it an additional 2. So at 6 pounds, we end there. You guys understand that graph? Do we need some more graphing problems with these greatest integers? So I know it's something kind of new, so I'm going to give you a little extra time to work than usual. So I'm actually done for today. The graphs on this one, it says give the domain and range, but I actually don't want you to do that. I just want you to draw the graph. Okay. Make sure you have a minimum of 3 steps when you draw your